factoring trinomials of the form x squared, excuse me, dry throat, plus bx plus c. Recall, a polynomial is in factored form when it's written as the product of two or more factors. Okay, so far we've only looked at common factoring, so let's just do these two. We're looking at common factoring. Largest number that goes into 14 and 28 is 14, and they both have an x, and we want the smallest power. So how do you get 28 to, how do you get x squared? We'll need an x plus, that sign is just going to come down. Remember, there's two terms here. We're going to need two terms in the bracket. And in order to get 14x, we just need a 1. Now, remember, always expand. So 28x squared plus 14x, check. So we've done a proper factorization. And also, are there any common factors still in here? Do they each have an x? No. Is there anything that goes into 2 and 1? No. Okay, on this one, largest number will be 3. They all have an a, and the smallest a is a to the 1. So I'm going to write an a. And that's it for common factors, since this term has no b. So how do I get 6? Really what you're doing is 6a squared divided by 3a, but I just say 3 times what gives me 6, a times what gives me a squared, minus 3 times what? 1. I've got a 3a already, so I just need a b here, minus, and these signs will be the same, and there are 3 terms here, so there will be 3 terms in the bracket. So 4a squared b. Okay, your checks. Number 1, is there a common factor of any of the numbers? No. I have 1, 2, and 4. Do they share any letters in common? No. Multiply it out. 6a squared minus 3ab minus 12a cubed. A squared times a is a cubed b. So that all checks. Now on to the real stuff. So today we're going to look at factoring a special type of polynomial, which is a trinomial in the form x squared plus bx plus c. How could we factor x squared plus 5x plus 4? Remember, we're going to write it as the product of 2 or more factors. We could use our knowledge of algebra tiles and rectangles to express x squared plus 5x plus 4 as a product of 2 factors, length and width. Think back to what we did with algebra tiles, and when I say the teacher demo, so this isn't on your worksheet, but here's a demo. So we're going to do another one. A rectangle has an area of x squared plus 4x plus 3. Make a rectangle with this area to determine the length and the width. Okay, so I'm going to need an x squared. Now I need 4 x's and 3 1's. Okay, so here I'm just going to drag 3 1's over here. 3, and let's figure out how I'm going to do the x's. So let's say I put 1 here. I'm going to need probably 1 down here. Now if you do that, you notice I can fill in one of the 1's, but I've only got 2. I need a couple of more x's. I'm going to put 1 here, and you'll notice that if I stack 3, here we've got our x squared, we have our 4 x's, and I have space for 3, so I can make a rectangle. And that's the idea, right, is we are going to make a rectangle. This rectangle has the area. That's called the simplified form. Its length is, well, this is x, and this is 1, 2, 3, so its length is, oh, I need a pen. Its length is x plus 3, binomial, write it in brackets, right? And that goes from there to there, and its width is x plus 1. And its product is x squared plus 4x plus 3. So the length is x plus 3, and the width is x plus 1. You normally wouldn't necessarily write the binomial in brackets, but I want to do that because I need to write this as a product. X plus 3, x plus 1. That's the factored form. So we get x plus 3 times x plus 1. Okay, let's do one more. A rectangle has an area of x squared plus 5x plus 6. Whoops. Control Z. I need a dragger, not a drawer. X squared. I need 5 x's and I need 6 1s. Let's just move the 6 1s out there so we sort of, I don't know what shape, but we do have to make a rectangle out of this. And so as I add my 5 x's, let's just try one down here. And you know, if I put 5 out this way, then I'll only be able to fit 5 units in here. So let's try this. So I need 3 more x's. So here's 1. Now if I put 3 out this way and 2 this way, I think I can fit my 6 1s in there, right? And the idea is make a rectangle, right? It's got to be a solid shape, and you notice I can fit my 1s in here. 3 along here, 2, 3, get in there, and 3 down here, 1, 2, and that's the 5th 1 and the 6th. So I have x squared. I have 1, 2, 3, 4, 5 x's and 6 1s. This distance, oops, now I need a pen. This distance here is x 1, 2, 3 plus 3. I like to put brackets around it, and this distance is x plus 2. So let's call the length x plus 3 and the width x plus 2. The area, right? Remember, area is what we call the simplified form, is x squared plus 5. You can just count it out of there, and that's equal to length times width. And therefore the factored form is length times width. Factor is writing it as a product, right? So two things multiplied together. All right, where were we? We were going to, well, we watched the demonstration on Algebra Tiles. So here we go. We were going to do x squared plus 5x plus 4. Determine the length and width by drawing the rectangle using Algebra Tiles. So we're just going to sketch it out. So we got an x squared. I've got 5 x's. You know, now if I put 2 here and 3 here, that's going to leave me 6 spaces. So what if I put 1, 2, 3, 4 here, and 1 here? Then I have space for 4 1s. 2, 3. Not the best drawing in the world, right? We get x plus 1. And we get x plus 4. So I'll go with the larger one is the length, x plus 4, and the width is x plus 1, and the area is length times width, which is x plus 4 times x plus 1, and therefore the factored form is length times width. Remember, the area model is that just looking at the area and counting, right, and these are x's, we have x squared plus 5x, and these guys are 1s plus 4, which is what I want, and the length and the width, their product, that's the factored form, x plus 4 times x plus 1. X squared plus 5x plus 6. Didn't we just have 5x? Yeah, we had 5x and 4. Oh, so remember, I think when I was thinking about that, there's my x squared. I said if I put 2 x's here, x and x, right, then I have 2 down, so 2 down and 3 across. These guys are all x's, leaves me with 1, 2, 3, 4, 5, 6. 6 1s. So that area is x squared plus 1, 2, 3, 4, 5x plus 6. And it's arranged in a rectangle. Length, well, we go with the longest one. This is x plus 3. Width, this is x plus 2. So the length and the width. And area is length times width. Must be written with the parentheses in, right? Without that, I don't know what you have exactly. If you wrote these together without parentheses, you would not have an expression in factored form. Moving on, but you know, we get into more complex questions. Algebra tiles would be too time consuming, right? And you know, if you want some physical tiles to manipulate, let me know. I can bring some in and give them to you. So, how would we factor without algebra tiles? So let's take a look at it. X squared plus 5x plus 4. We did this one, right? The factored form is x plus 3 and x plus 2. No, wait, that's this one down here. Hang on, can I move that? Yeah, there we go. X squared plus 5x plus 4 was x plus 4 and x plus 1. Well, we have some factored forms here. Let's go backwards. So this will be x squared plus 6x plus 7x. Remember, you're foiling, so you're getting 4 products plus 7x plus 42. So the simplified form, so, you know, we have to collect these middle terms together, right? We can't just leave them. Simplified form can't have 2 sets of x's. So x squared plus 13x plus 42. This one, oh, minuses, right? Because how do we do minuses with tiles? So again, let's use x squared minus 3x minus 5x plus 15, which always reminds me of those things downtown. And collecting, we get x squared minus 8x plus 15. X squared, so here we have a mixture of positive and negative, minus 5x plus 12x minus 60, which becomes x squared plus 7x minus 60. And x squared plus bx plus c. So the question is, how do we write that as a factored form? Well, if it's factorable, then factors will be of the form x plus p, x plus q. So here, let's just write this in. We'll just say it's x plus p times x plus q. Now, what happens when we expand x plus p times x plus q? I'm going to see if it's on the next page. Well, let's just do it down here. So you multiply that out, you FOIL it, you get x squared plus qx plus px plus pq. And we sort of start to see, well, how does this relate? The x squared, well, that's there. The c value, that's just going to be this guy. And the b value, that's going to be a combination of these two. So let's go look at that in a little bit more detail. So in the table above, if you examine the constant term and the coefficient of x of the trinomial in simplified form, and look at the values of p and q in factored form. So let's back up a bit. So you look here, 42, hey, 42, plus 15, minus 60, minus 60. So this last value came only as a product of the last two values, right? PQ. And the middle one, 6 plus 7, 13. Negative 3 minus 5, negative 8. Negative 5 plus 12, positive 7. That middle term is a combination of the outer and inner products. Okay, so one more time. If we multiply this out, x squared minus 5x plus 12x minus 60. So we can see that p times q, these two guys here, P times Q is equal to C. It's the constant term. And P plus Q, so in this case, positive 12 plus negative 5. P plus Q is going to give you the B value. Right? Here, let's simplify. X squared plus 7x. See, that's P plus Q plus 7x minus 60, and that's P times Q. So in other words, to factor x squared plus bx plus c, we need to find two numbers that multiply to give us c, and the same two numbers add to give us b. So they multiply to give us the last term, and their sum is the middle term. All right, factor x squared plus 11x plus 28. So the first step, is there a GCF? Is there a number that goes into all of these? Is there? No, there isn't, okay, because we got a 1x squared. The second step is to recognize the type of polynomial. Is this of the form x squared plus bx plus c? Yes, it is. So that's what we'll call that a simple trinomial, while the printer fires up in the background. Since this polynomial is the form x squared plus bx plus c, we need to find two numbers that multiply to c and add to b, which in this case is multiply to 28 and add to 11. In this case, positive 11 and positive 28. So the two numbers are 7 and 4. Is there any other combination? Well, multiply to 28, right? So we start thinking about 28 as a factorization. 1 times 28, 2 times 14, 4 times 7, 5, 6. No, and then we repeat, right? Because we'd go to 7 times 4. So these are the only ones. Well, those add to 29. Those add to 16. More printing. These add to 11. So are there any other combination? No. So the factored form is x plus 7, x plus 4. Now here's the deal. Whenever we factor, we always expand. I'm going to talk over this. So we FOIL it. We're going to get four products. X squared plus 4x, inner plus 7x, last plus 28. Which is x squared plus 11x plus 28. This step is crucially, vitally important, must always, always, always be done, because the mistakes that happen in factoring are usually not finding the numbers, but it's getting the signs, right? And we haven't even looked. These are all pluses, so it's really easy. We know these two have to be pluses. It's looking at the signs and getting them right. And we'll see that as we do some more examples. So here, notice we have a negative sign here. So is there a greatest common factor? No. Is it of the form? Yes. All right, since we're of the right form, we need two numbers that multiply to c, which is 24, and add to negative 10. All right, now here's how I look at these. Right? I say, if you're going to multiply to a positive, but add up to a negative, then both of the numbers will have to be negative. And they are negative 6 and negative 4. There's no other combinations, right? And again, you say 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then we'll get into repeating. And so here's the thing. There is a difference between 2 and 12. There's a difference of 10. So if I had a minus 12 and a plus 2, that would give me a negative 10. But if I had a minus and a positive, so here's what I look at. If the last term is positive, then both factors, both of the numbers we're looking for, have to have the sign of the middle term. So I need two negative numbers. And so the only two numbers that will add to negative 10 are negative 4 and negative 6. So there is no other combination. So the factored form will be x minus 6, x minus 4. Check your answer by expanding. Okay, so this is my big thing for factoring, Janover's factoring method. If the last term is positive, then either both numbers are positive, right? Or they're both negative. Two positive, if this is positive, it comes from two positive numbers or two negative numbers, right, to give us that product. And what sign do we have when we're looking for positive or negative? The middle term will tell us that. A negative middle term tells us that both of our factors must be negative. Let's expand this out. So using FOIL, oh my god, I'm in a loop. I'm going to pause this while it does stuff. Okay, I think it was auto-saving or something. So FOIL, four products, so that's equal to x squared, outer, minus 4x, inner, minus 6x, and last, plus, notice, negative times negative gives you plus 24. So that plus 24 can be the product of two positive numbers or two negative numbers, but the middle term tells us that it has to be, oh wait, these are all A's, A, it's very Canadian, A. So A squared minus 10A plus 24, and really it is vital that you, every time you factor, you check, okay? Because maybe you'll end up with a positive 12. Maybe you thought it was A minus 12 and A plus 2, right? They multiply to give you 24. Unfortunately, they give you negative 24, so immediately you should say, well, that's not it. But if you multiply this out, you'll get A squared plus 2A minus 12A minus 24, which is A squared minus 10A. So you might be happy at this point. Look, I have a minus 10A, but now you should be sad because you have a minus 24 and it needs to be a plus 24. That's why we always check it. Always, 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 always. Is there a greatest common factor? There is. Notice how they're all divisible by 3. Oh my god, what's going on with this? Okay, I'm going to pause. It's doing an auto. Okay, I think we're back. Let's get rid of that. So 3, greatest common factor. Yes. What is it? It's a 3. So take a 3 out. Now you notice there's no m that's common to everything. So 3, m squared minus 2m minus 8. Signs are going to stay the same. There's 3 terms in the original. There must be 3 terms in the bracket. This factor is of the form x squared plus bx plus c. We need two numbers that multiply to negative 8 and add to negative 2. Okay, here's how I think about these. I say, if I have a negative product, the only way to get a negative product is to multiply a positive times a negative, right? One factor has to be positive, and one factor has to be negative. So I need two numbers that multiply to 8. So at this point, I'm not worried about the 8, negative 8. And I'm not worried about the negative 2. So what I want is this. Two numbers that multiply to 8 and differ by 2. So I say, instead of saying add to negative 2, I say they differ by 2. And I know that the larger number has to be negative, right? Because when I add the two numbers together and they differ by 2, I know I need to get a difference of negative 2. So the numbers are, well, the two numbers that multiply to 8 and differ by 2 are 4 and 2. And I'm going to make the 4 negative. Since the middle term is negative, it tells me the larger number must be negative. So the factored form, we've still got the 3. We're going to have m minus 4, and we're going to have m plus 2. Check your answer by expanding. Okay, so watch this expansion, because this goes with what I do my factoring by what I call a pattern of signs, which is if the last term is positive, both factors are positive or both factors are negative, and the middle term will tell me which. If the last term is negative, then I have a positive times a negative. And actually, I should be looking at this, not that. If the last term is negative, I have a positive times a negative, and this middle term just tells me what the bigger number is. In this case, the bigger number is negative. Okay, so first I'm going to multiply these out. M squared, FOIL, plus 2m minus 4m minus 8 which is m squared minus 2m minus 8, middle term collected, right? So we're there, and that's 3m squared, right? This is also a factor, minus 6m minus 24. And now we should be looking, is this the original? Yes, it is. Okay, one more. This is a little cut off, but it's factor x squared plus 2x plus 7. So there is no greatest, oh my god, there is no greatest common factor. No, right? Because that's a 1. Is it of the form x squared? Yes. We need two numbers that multiply to 7 and add to 2. Now in this case, we know they're both positive. Why? If you multiply to positive 7, it's a plus times a plus or a minus times a minus. If it's two negatives, the middle term will be negative. So it has to be two positive numbers. The only numbers that multiply to 7 are 1 and 7. So the problem is, I can't find the numbers. So if you tried to do this with algebra tiles, right, I mean, you could do an x squared, and you could put like 2 tiles here. That would give you your 2x, or you could put 2 tiles here, or you could put 1 tile here and here. That would give you 1 to fill in. 2 tiles here would give you, well, there'd be nothing. There'd be, you know, wouldn't need to fill it in. You have a rectangle. And here you wouldn't need to fill it in. You have a rectangle. So we can't build a rectangle. So this is not factorable, which means that not every trinomial can be factored. So the answer is no. You can't always factor. You may not be able to find the numbers. And of course, there's two possibilities. You can't find the numbers because they don't exist, or you just don't see them. So we're done now. We're into exercises. We're 27 minutes in. What I'm going to do is just whip through the exercises, just basically showing you this is exactly how I would do them. You should be doing these on your own, and then you can come and check, but I'm going to show you. So p times q is 6. P plus q is 5, so I'm multiplied to, and I'm saying differ by, right? Differ by. So the values for p, so two numbers that multiply to 6 and differ by 5. So 2 and 3 multiply to 6, but they add to 5, and I need them to differ by 5. So it's 6 and 1. I need, remember, I need a positive and a negative. So I need a positive 6 and a negative 1. Why 6 positive? Because the middle term is positive, so the larger number. So x plus 6, x minus 1. Do a quick mental check. X squared minus 1x plus 6x is plus 5x minus 6. Yes, so that works. So I'm done. Now you notice, here we have a plus, which means they have to be the same sign. And here we have a minus, which says they both have to be negative. And they're going to add to 5. Okay, they're really going to add to negative 5, but I'm just going to say they add to 5. So they mult to 6. They add to 5. They're both negative. So it's negative 2 and negative 3. X minus 2. Now the order you write these in doesn't matter. X squared minus 3x minus another 2x is minus 5x plus 6. Okay, multiply to 6, differ by 1. There's a 1 positive and 1 negative. The bigger one is positive, so the numbers are 3 and negative 2. X plus 3, x minus 2. X squared minus 2x plus 3x is plus 1x minus 6. Multiply to negative 20, they have opposite signs. They multiply to 20, they differ by 1, so 20 and 1, and they will be negative 5, positive 4, right? 5 and 4 multiply to 20 and differ by 1, their difference. The 5 is negative because the larger number is negative, right? So I get x minus 5, x plus 4. X squared plus 4x minus 5x is minus 1x. Oh, really? Okay, hang on. They're y's. And then minus 20, right? Checked. Multiply to 20, 1 positive, 1 negative, and they differ by 3, right? When it multiplies to a negative, they differ by 3. So I need numbers that multiply to 20 and differ by 3. 1 and 20, no. 2 and 10, no. 3, 4, 4 and 5, no. So does this say factor if it can be factored? If possible. So it is not possible to find two numbers that multiply to 20, and because of the minus, their difference is 3, right? Numbers that multiply to 20 are 1 times 20, and their difference is 19. 2 times 10, remember, I know 1 is positive, 1 is negative, and I know the bigger one is positive, and 4 times 5. And after that, we just get to 5 times 4, and so on. So this differs by 1, this differs by 8, this differs by 19. This is not factorable. Multiply to 12, add to 8. When that's a positive, they add to 8. They're both negative. So multiply to 12, add to 8, negative 6, negative 2.
30 seconds.
Oh my God, 30 seconds. Well, they're just going to go on. So x squared minus 2x minus 6x is it's y's. Minus 2y minus 6y is minus 8y. And then a negative times a negative is positive 12. Oh, I don't like this. So I'm going to rewrite this. Okay, so two numbers that multiply to 24 differ by 5. Okay, multiply to 24, add to 5. It's really negative 5. I don't think of it that way, so I'm not exactly filling this chart in commonly, but the numbers are 8 and 3, and the larger number is negative since the middle term is negative. So this is x's. Oh no, it's b's. B and b plus 3. B squared plus 3b minus 8b is minus 5b minus 24. Oh, wow. I don't like that. So here's what I'm going to do. I'm going to go negative in front and then go n squared minus 4n minus 45. So I always want to factor things with a positive n squared. So two numbers that multiply to 45 differ by 4. I'm going to write differ by 4. Okay, negative 9, they're 9 and 5. They differ by 4. And it will be, so put the negative sign out front. We're going to have n minus 9, n plus 5. Okay, n squared plus 5n minus 9n will be minus 4n minus 45. So negative n squared minus 4n minus 45. Okay, and then we can change that to negative n squared plus 4n plus 45. Okay, again, remember you're doing these. I'm just doing it. This is a resource that you can use afterwards. This won't appear in class. Okay, two numbers that multiply to 21 and add to 10. So I think about it, right? I got 1 times 21. Got 3 times 7. Oh, those will work. This is positive, saying that both terms have the same sign. They're both positive or both negative, and this says they're both positive. So x plus 3, x plus 7. What's the area when x equals 3? So we substitute 3 in, which is 6 times 10, which is 60. What is the length and the width when, oh, I guess the area, sorry, should have gone in here. So 3 squared plus 10 times 3 plus 21 is 9 plus 30 plus 21 is 60. What's the length and the width? Okay, so 6 and 10. So my bad. I just got to watch your order. Factor completely. Okay, common factor, 2m. M squared minus 7m minus 18. Okay. Okay, for real, how do you do it? You put an m here and an m here because you're going to get m squared. Excuse me. Two numbers that multiply to 18 differ by 7 are 9 and 2. The 9 will be negative since the larger term is negative. You can verify this. Let's take out a negative 4t, giving me t squared. Signs are going to change. Plus 4t, and this will be minus 32. Okay, so we get negative 4t. Okay, we know we lead with t's. Whoops, need a set of brackets. So write down two sets of brackets, put down the t's. Negative 32, multiply to 32, differ by 4. That's 8 and 4. The 8 will be the larger number is positive, right? T squared minus 4t plus 8t is plus 4t minus 32. And that is done. And I will finish these off a little bit later. Okay, here I am, back a few hours later and finishing these two exercises. So find all the values of k. So what we know is we need two numbers that are going to multiply to positive 24. So positive 1 and positive 24. And if we use those, k will be 25. If we use 2 and 12, then 2 plus 12 is 16. If we use 3 and 8, then k will be 11. So these are the values of k. If we use 4 and 6, then k will be 10. Okay, now if we keep going, we're just going to end up repeating these 6 and 4, 8 and 3. So basically we just need to be able to do all the factorizations of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Done. These values, now since those are both positive, so just for example, this will be k plus 1, k plus 24. Now, to get positive 24, I can also do each of these pairs again, but where they're both negative. So what we really get is plus or minus 25, plus or minus 16, plus or minus 11, plus or minus 10. So to give an example, what if I had k minus 4, k minus 6? So k squared minus 6k minus 4k is minus 10k plus 24. You see how we get a plus 24 out of two negatives? Or if these were both positive, that would be plus 24. This would be plus 10k, hence the plus or minus 10. So those are all of the values of k that will make this trinomial factorable. Okay, what about here? So we need negative 12. So that's negative 1 and positive 12. Well, if you add those two together, you're going to get 11. But you could also do positive 1 and negative 12, which will give you negative 11. You can do negative 2 and positive 6, which will give you 4. And you can do positive 2 and negative 6, which would give you minus 4. And I think you can see the pattern here, right? We basically need all the factors of 12. 1 and 12, 2 and 6, 3 and 4. Now, what are we doing? We're really taking the difference between them, since we know one is positive, one is negative, and the difference between them. So this will give a k value of plus or minus 11. This will give a k value of plus or minus 4, and this will give a k value of plus or minus 1, right, based on difference. So two numbers that multiply to 12, but because of the negative, they differ by k. So they differ by 11, right? And here's the two ways we get it, and so on. Last one. Find a positive and negative integer value of k such that x squared plus 5x is plus k can be factored. So here we're really looking for numbers that add up to 5, right? Now that's positive, so they both have to be positive, or one number is greater than the other. So we could use like 1 and 4, right? Positive 1 plus positive 4. Now remember, k is made up of the product of the two factors, so we get a k value of 4. Well, what else adds up to 5? How about 2 and 3? 2 and 3 add up to 5. 2 times 3 is 6. What else adds up to 5? Well, can I use 5 and 0? Well, that'll give us a 0 here, and yeah, you know, x squared plus 5x plus 0 can be factored, so 0 and 5 gives us a k value of 0. find a positive and a negative integer value of k. All right, well, there's some positive values, so can we get a negative value? So how about 7 and negative 2? 7 plus negative 2 is positive 5, and k will be negative 14. How about 27 and negative 22? Right, and I have no idea what that multiplies out to, but how many values of k are possible? Lots. Or infinitely many. All I need is two numbers that add to 5 or that differ by 5, right? Well, again, just add to 5, but in this case, so really I guess the difference here isn't 5, it's just 7 plus negative 2. So we can use any number, and that will give us numbers. So I think in general you could say, well, I can use p and I can use 5 minus p. Okay, and then our k value would be 5p minus p squared. I don't know if that really does us anything. You know, but if I say, well, p is 1, we get 5 minus 1, which is 4. P is 2, we get 10 minus 4, which is 6. And, you know, it gives us an expression, I guess, for you know, one of the numbers and then the other. So, you know, nothing we really have to worry about here. They're just infinitely many values. And that finishes, I believe, that finishes all of the exercises. So that's kind of your video bonus, working through here, using my pattern of signs to do the factorizations. And I hope that's helped if you've had any difficulties with the exercises. And I'll save this, of course, so that I can put it up, and we're done.